I don't think people understand the true power of the sun's awakening and its potential impact on Earth. Our planet basks in the warmth of the sun, a celestial giant that has nurtured life for billions of years. Yet, beneath its seemingly tranquil surface, the sun simmers with immense power. It is a power that can both sustain and disrupt our modern world. In recent years, this power has been on the rise, with the sun entering a period of heightened activity. This surge in energy manifests as solar storms, awe-inspiring events that hurl charged particles towards Earth at incredible speeds. These solar storms, while capable of painting our skies with breathtaking auroras, also possess the potential to wreak havoc on our technology-dependent society. From disrupting communication networks to impacting power grids, their effects can be far-reaching. As we journey further into 2025, understanding and preparing for these solar events becomes increasingly crucial. We must learn to live with the awe-inspiring power of our sun, respecting its potential while safeguarding our technological infrastructure. The study of space weather, a field dedicated to understanding and forecasting these solar events, is more important now than ever before. By unraveling the mysteries of the sun, we can better anticipate and mitigate the impacts of its inevitable outbursts. In this era of increasing reliance on technology, our ability to adapt to the sun's volatile nature will be paramount in ensuring the smooth functioning of our interconnected world. At the heart of our solar system lies the sun, a colossal ball of plasma and magnetic fields. Within its fiery depths, a constant battle between pressure and gravity generates unimaginable amounts of energy. This energy, released in the form of light and heat, sustains life on Earth. However, the sun's energy output fluctuates in cycles. During solar maximums, the sun's magnetic field becomes more complex, leading to sunspots, solar flares, and coronal mass ejections. These phenomena can disrupt radio communications and pose hazards to astronauts. Coronal mass ejections can trigger geomagnetic storms, affecting power grids and satellite communications. Scientists track the sun's activity through solar cycles, which last approximately 11 years. Each cycle is marked by periods of high and low activity, with the peak of activity known as solar maximum. We are currently in solar cycle 25, which began in December 2019. While initially predicted to be a relatively quiet cycle, solar cycle 25 has surprised scientists with its intensity. The sun has been more active than anticipated, with numerous sunspots, solar flares, and CMEs observed. This heightened activity has led to an increase in geomagnetic storms on Earth, some of which have been quite significant. In May 2024, for instance, a powerful geomagnetic storm, the largest in 2 decades, triggered widespread auroras, visible even at lower latitudes. The storm also caused disruptions to satellite navigation systems, highlighting the potential impact of such events on our technology-dependent world. The increased activity in solar cycle 25 is a reminder that our sun is a dynamic and unpredictable star. While scientists can track the sun's activity and make predictions about potential solar storms, the exact timing and intensity of these events remain difficult to forecast with certainty. This uncertainty underscores the importance of continued research and monitoring of the sun, as well as the development of strategies to mitigate the potential impacts of solar storms on our planet. As we delve into 2025, the sun continues to exhibit its restless nature. The early months have witnessed significant solar events. In January, a powerful X1 class solar flare erupted, sending radiation towards Earth. This flare disrupted radio communications in some regions. Such events impact our technological infrastructure. Observations revealed 2 coronal holes, one large in the north and a smaller one in the south. These holes are sources of high-speed solar wind streams. These streams can trigger geomagnetic storms. We can expect more geomagnetic storms in the coming months. These storms offer a mesmerizing spectacle, the auroras. Charged particles from the sun excite atoms in Earth's atmosphere, causing them to glow. This glow, known as the aurora borealis in the north and aurora australis in the south, paints the night sky with vibrant hues. Section 5. Auroras, the dazzling spectacle of solar storms. Auroras, often referred to as the northern and southern lights, are one of the most captivating natural phenomena on Earth. Triggered by the interaction of charged particles from the sun with Earth's atmosphere, auroras transform the night sky into a celestial ballet of light and color. Imagine standing beneath a star-studded sky as shimmering curtains of green and red dance across the horizon. This ethereal display, a testament to the sun's immense power and our planet's magnetic shield, is a sight that has captivated skywatchers for centuries. The colors of the auroras are determined by the types of atoms that are excited by the solar particles. Green, the most common color, is produced by the excitation of oxygen atoms at lower altitudes. Red, often observed at higher altitudes, is also produced by oxygen, while blue and purple hues are the result of nitrogen excitation. These colors, combined with the constantly shifting patterns of the auroras, create a truly mesmerizing spectacle that has to be seen to be fully appreciated. During periods of heightened solar activity, such as the one we are currently experiencing, auroras become more frequent and intense. They can also be seen at lower latitudes than usual, as the increased energy from the sun pushes the auroral oval, the region where auroras are typically observed, further towards the equator. This means that even those living far from the polar regions may have the opportunity to witness these dazzling displays of light. Section 5. Auroras, the dazzling spectacle of solar storms. Auroras, or the northern and southern lights, are captivating natural phenomena. Triggered by charged particles from the sun, auroras transform the night sky into a celestial ballet of light and color. Imagine standing beneath a star-studded sky as shimmering curtains of green and red dance across the horizon. This ethereal display, a testament to the sun's power and our planet's magnetic shield, has captivated skywatchers for centuries. The colors of the auroras are determined by the types of atoms excited by solar particles. Green is produced by the excitation of oxygen atoms at lower altitudes. Red, observed at higher altitudes, is also produced by oxygen. Blue and purple hues result from nitrogen excitation. These colors and shifting patterns create a mesmerizing spectacle. During heightened solar activity, auroras become more frequent and intense. They can also be seen at lower latitudes as the auroral oval expands towards the equator. This means even those far from polar regions may witness these dazzling displays. Section 6. Impacts on our technological world, navigating the disruptions. While auroras serve as a beautiful reminder of our sun's power, solar storms can also pose significant challenges to our technology-dependent world. The same charged particles that create the auroras can disrupt radio communications, GPS systems, and power grids, potentially impacting our daily lives in a myriad of ways. Imagine a world without reliable internet access, accurate GPS navigation, or even electricity. These are just some of the potential consequences of a major solar storm. One of the most vulnerable sectors is the power grid. When a CME hits Earth's magnetic field, it can induce electric currents in long conductors such as power lines. These currents, if strong enough, can overload transformers and other grid components, leading to power outages. In 1989, a powerful geomagnetic storm caused a 9-hour blackout in Quebec, Canada, affecting millions of people. The event served as a stark reminder of our vulnerability to solar storms. Satellites, orbiting high above Earth, are also susceptible to the effects of space weather. Solar radiation can damage sensitive electronics, while the increased density of the atmosphere during geomagnetic storms can increase drag on satellites, potentially leading to orbital decay. GPS signals, reliant on precise timing from satellites, can be degraded or even lost during solar storms, impacting navigation systems used for transportation, surveying, and even emergency response. Section 7. Echoes from the past. Significant solar events in history. Throughout history, there have been numerous instances where solar storms have left their mark on Earth and its inhabitants. One of the most famous events, the Carrington event of 1859, serves as a stark reminder of the potential power of our sun. During this event, a massive solar flare and CME unleashed a geomagnetic storm of unprecedented intensity. Auroras were observed as far south as the Caribbean, and telegraph systems worldwide went haywire, with some operators reporting electric shocks and fires. In more recent times, the 1989 Quebec blackout, caused by a geomagnetic storm, highlighted the vulnerability of power grids to solar events. The blackout, affecting millions of people for 9 hours, served as a wake-up call, prompting increased research into space weather and its potential impacts on our infrastructure. While the Carrington event and the 1989 Quebec blackout are among the most well-known examples, there have been countless other solar storms throughout history, some causing disruptions to radio communications, others triggering stunning auroral displays. These events, etched in our planet's history, serve as a reminder that the sun, while life-giving, is also capable of unleashing forces that can impact our technological world. Section 8. Preparing for the solar storm, shielding our world from the sun's outbursts. As we become increasingly reliant on technology, preparing for the inevitable impacts of solar storms becomes paramount. Fortunately, there are steps we can take to mitigate the risks and ensure the resilience of our infrastructure. Just as we prepare for earthquakes and hurricanes, so too must we prepare for the potential disruptions posed by our sun. One crucial aspect of preparedness is early warning. Space weather forecasting centers around the world, using a network of ground-based observatories and spacecraft, constantly monitor the sun for signs of potential solar storms. These centers issue alerts and warnings, providing valuable time for power grid operators, satellite operators, and other stakeholders to take preventative measures. Hardening our infrastructure is another essential step. This involves designing and building power grids, satellites, and other critical systems to withstand the effects of geomagnetic storms. For example, power grid operators can implement systems to protect transformers from voltage surges, while satellite manufacturers can use radiation-hardened electronics to enhance resilience against solar radiation. Section 9. Conclusion. The importance of space weather awareness. As we venture further into the 25th solar cycle, understanding and respecting the power of our sun becomes increasingly crucial. Solar storms, while capable of producing breathtaking auroras, also have the potential to disrupt our technology-dependent world. By raising awareness about space weather, investing in research and forecasting, and implementing mitigation strategies, we can reduce our vulnerability and ensure a brighter future for all. Just as we monitor weather patterns on Earth, so too must we keep a watchful eye on the sun. By doing so, we can navigate the challenges posed by solar storms and harness the sun's energy for the benefit of humanity. The future is bright, but it is up to us to ensure that we are prepared for the storms that may come our way.